Good morning. This recording is for Algebra 1, Chapter 8, Lesson 4, Multiplying Special Cases. You need to understand these. You need to understand how they work. You need to be able to do these problems without actually knowing the special cases. But if you can do them and understand them and use the shortcut, because this is basically a chapter full, this lesson is full of shortcuts, they will really help you do math so much faster, and even without a calculator, depending on how good you feel about multiplication facts. So I really do recommend that you at least memorize this. You have to understand it to do well, but memorizing it will help you go so much faster. If you can just understand how this works. Okay, so the first special case is the square of a binomial. So basically we're taking a binomial, so inside parentheses we got two terms that are either being added or subtracted, and that's being squared. So it looks something a lot like this. So a plus b squared, when you do the shortcut, or excuse me, when you don't do the shortcut, it ends up being a plus b times a plus b. Because remember, everything's that's inside the parentheses is being multiplied by itself. So a plus b times a plus b. The only thing is the shortcut is that if you know what a is and you know what b is, well, even if you don't, because you know how to multiply variables at this point in your life, you can use this shortcut right there. That's the shortcut. It's a squared plus 2ab plus b squared. That is the shortcut. You can skip having to do a ton of math if you can remember that, okay? And that is when you have a plus b squared. If you have a minus b, it looks very similar. The only thing is you have a subtraction sign right there, which looks a lot like that. So again, if you have the minus, a minus b, this is the only difference between here and here, right there. Those are the differences, okay? So if you can memorize this special case, it's going to make your life a lot easier, because look at all this work you have to do. This is why it works. The first example at the top is 2 plus 6 squared. All right? Now, if you were to go through and do this the way that I taught you yesterday, you're going to have to FOIL, or you can do the basically the breakup. I called it the king pig yesterday, or in the last video. Some of you guys are going to know what that means. Some of you are not. Don't worry about it. But both are acceptable, because remember, there's two ways to do this. So once you FOIL and simplify, you're going to end up with the same pattern, where it's the first number in the binomial, in this case t squared, plus 2 times a times b, which in this case was t and 6, so that would be 2 times t times 6, which ends up giving you 12t right there. Let me use a different color, actually. There we go. So this is, a squared. This is 2 times a times b, and this ends up being b squared. Well, when b was 6, 6 times 6 is 36. So it ends up being this pattern that ended up showing up every time you did a binomial square. That it's going to be the first number squared. The second term in the answer is going to be 2 times the first times the second, and the third term is going to be the second one in the binomial squared. All right? And again, the same works for when you have a subtraction, when you have a binomial that has subtraction in it. It's going to be the first term squared, so 7 squared is 49, m squared is m squared. It's the second term in the answer is going to be the first term times the second term times 2. Well, 7 times 2 times 2 is 28, because 2 times 2 is 4, 4 times 7 is 28, and since it was ends up being a negative 2 at some point. That's where this whole negative 28 comes from. But then you can always just write plus negative as a subtraction problem. And then the third term is going to be the second term squared. All right, and it's probably really hard to see that because it's going to be that one squared. All right, so again, it's this pattern that kept showing up. And they're like, hey, well, if it works every time, it works every time. Well, let's just call it a special case. And since it's a special case, memorize it, use it. Let yourself skip a majority of these steps. Because if you can, you can. And, you know, it works and it works and it works. So use it, all right? So let's do an example problem. The first one's going to be a plus b squared, all right? So we have something plus something squared. In this case, 5y plus 1 squared. Well, the 5y is the a, the 1 is the b. And if you remember this shortcut up here, it needs to look like that. So we're going to take the a and we're going to square it. So that would be 5y squared. All right? Then we're going to take 2 times a times b, which would be 2 times 5y times 1. And then we're going to take b squared, which was just 1, and square it. Okay? So let's go ahead and simplify this. Remember, the 2 on the 5y is going to basically distribute. And we're going to get 5 times 5, which is 25, y to the second, because y to the second is y to the second. And then let's simplify the center part. So everything in there is being multiplied. This, you know, is a multiplication, 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 right? Or the dots, since there's letters now. So 2 times 5 is 10, times y is y, times 1 is just 10y, all right? And then 1 to the second power is just 1. Guess what, guys? That's your answer. Isn't this little bit of math you just did so much better than this? Yes. Not having to FOIL if you have a shortcut is going to be worth it. It's going to save you time on tests. It's going to save you mental anguish. It's going to help you get through your problems that much faster. Okay, so back to where I was, which was the answer. All right, oop, too far. Okay, so let's go ahead and do this next problem. We have a minus b squared situation, 9c minus 8 squared. So let's go ahead and use our shortcut, which is right there. We have a squared. Well, that would be 9c squared, right? Minus 2 times a, which is 9c, and times 8, which is just 8. Now, since this situation here ends up getting taken care of here, you could add the opposite and then use this situation, but since it's a minus, you just keep b as b. Even though you could write it as plus negative 8, you would just end up using this with the plus sign. So don't worry about the negative right there, or the subtraction right there. It ends up getting taken care of with the fact that we already know which special case we're taking care of. All right. Onward, the third term in the answer is going to be b squared. Since it's 8, since b is 8, it's going to be 8 squared. So let's go ahead and simplify this. Distribute, we're going to end up with 81c minus 2 times 9 times 8 is 144. So it's going to be 144c plus 64, because 8 squared is 64. There's your answer. All right, let's move on. So this is a special case situation, and actually this also works out with Punnett squares, which you should all be familiar with because of science. There's a really great Punnett square on page 389 in your textbook. I highly recommend it. It has Labradors, so it's very cute, so go check it out if you'd like. But something that I do expect you to be able to do and understand is rolling dice and the probability. This is a very simple, relatively elegant expression for figuring out the probability of rolling dice. So let me read the question to you. When playing a game with 2 cube dice, and you guys are all familiar with cube dice, just regular playing dice, you can find the probability by squaring a binomial. Let A represent rolling a 1 or a 2, and B represent rolling a 3, 4, 5, or 6. Okay? The probability of A is 1/3, and the probability of rolling B is 2/3. Now think about it. Let's talk about the probability of A. We have a 6-sided dice. It's a cube dice. It has 6 sides. Right? So visualize the dice or pull one out and look at it. Now, there's the numbers 1 through 6 on it, right? So if we're looking at situation A, which is rolling either a 1 or a 2, one side on that dice has a 1, and a second side on that dice has a 2. That means if you are just caring about rolling a 1 or a 2, and it doesn't matter which one you roll, you know, you'd be happy if you got a 2 and you'd be happy if you got a 1, you have a 1/3 chance because you want 2 numbers out of the 6. Well, 2 numbers out of 6 is really the same as 1/3 because you're simplifying fractions, okay? So that's situation A. Situation B says that you don't care whether you roll a 3, 4, 5, or 6. So those are 4 numbers out of the 6 possible numbers you could roll that you care about. So that's 4 out of the 6, which again, if you simplify, is 2/3. So do you now understand where we got this fraction and this fraction from? I hope so. I hope so. All right? So there we go. Now let's go ahead and talk about it. Now, they tell you that the probability of these situations happening is 1/3 A plus 2/3 B squared. That means that on one dice, rolling a 1 or 2 is a 1/3 chance, or rolling a 3, 4, 5, or 6 is a 2/3 chance. So, here's how it's going to work. We're going to go ahead and do this special case, and then I'm going to tell you what it means in relation to the questions below for B, C, and D. So special case this sucker. 1/3 A is A, 2/3 B is B. So let's go ahead and plug it into A squared plus 2AB plus B squared. All right? So that's the formula we're plugging it into. So the first term in the binomial is 1/3 A squared, which is the same as, oh, nope, never mind. I went ahead and wrote it out. So, okay, so let's go ahead and simplify this. So 1/3 A squared is going to be 1/3 squared, right? So that we're distributing times A squared. So 1/3 squared means the 1 gets the square and the 3 gets the squared. So it's going to be 1 squared, which is just 1, and 3 squared, which is 9. So that ends up equaling 1/9 A squared. Okay, because again, you guys remember this from last chapter. You need to be familiar with that. There you go. Okay, so let's go ahead and simplify the 2 times 1/3 A times 2/3 B. Well, 2 is a fraction, is 2 over 1. 2 times 2 is 4. 2 times 1 times 2 is 4. 1 times 3 times 3 is 9. So this ends up being 4/9 AB. All right, plus 2/3 squared times B squared. Well, 2 squared is 4, 3 squared is 9. Again, remember this, guys. Good. So that's going to be 9/4 B squared. So let me go ahead and write out the answer again, now that I've done all this work. There it is, big purple letters. 1/9 A squared plus 4/9 AB plus 4/9 B squared. Now, what does this mean? All right? So basically, if you look at it, A squared means it's the probability that both dice are going to have an A situation. Both dice are going to roll either a 1 or a 2. All right? It's 1/9 of a chance that both dice are going to show an A situation. Whereas there is a 4/9 chance that one dice will have an A situation and one dice will be a B situation. Whereas there's also a 4/9 chance that both dice are going to show a B situation. So if you have A squared, that means both dice have A. If you have an A and a B, it means one dice has an A situation and one dice has a B situation. And B squared means that both dice have a B situation. So let's go ahead and look at the next question. Letter B. What is the probability that both number cubes you roll show a 1 or a 2? Well, that would be both cubes showing an A situation. So that is actually 1/9. Actually, here we go. So just so you remember, A squared is both dice. B, A and B is one dice showing A, one dice showing B, doesn't matter which. And B squared would be both dice showing B. So there we go. So the probability that both dice are going to show an A situation is 1/9. The probability that one dice cube shows a 1 or a 2 and the other shows a 3, 4, 5, or 6, again, one dice showing an A situation, one dice showing a B situation is 4/9. And the probability that both cubes, both dice, show 3, 4, 5, or 6, which is a B situation, is 4/9. Okay? All right. That was probably the longest word problem explanation ever, but you know what? I think you guys are going to figure it out. We can talk about it more in class. Okay, so some mental math, something a little bit more peaceful. So, 31 squared. There's a way you can do this using a special case. Especially if you don't have a calculator, this might really help you out. So, this is basically what we call a king-pig problem, or at least what I've taught some other kids as understanding as a king-pig problem. I really don't want to do 31 squared. It's going to involve a lot of math. I really don't want to do it. So let's come up with a simpler way to do it. So I'm going to break up 31. I'm going to break it up into 3 plus 1, because 3 plus 1 is still 31 squared. Well, I can do this as a special case. I know that a plus b squared is the same as a squared plus 2ab plus b squared. So what's a squared? Well, the 30 squared, 3 times 3 is 9, plus 2 zeros is 900. And then we have 2ab, which is 2 times 30 times 1, plus 1 times 1 squared. There you go. So 30 squared is 900, because again, 3 times 3 is 9 plus 2 zeros, right? Because it's the same as 30 times 30. That one's pretty easy to do mentally. 2 times 30 is 60, times 1 is still 60, and then 1 squared is just 1 squared. Yeah, so then just add them up. 900 plus 60 plus 1, 961. Pretty easy, cheesy, lemon squeezy. Again, if you don't have a calculator, use this tool. All right, next up, 98 squared. Well, 98 is really close to 100, especially if I minus 2. So this is going to be 100 minus 2. Guess what, guys? Still a special case. So this one's going to be a squared minus 2ab plus b squared. Ta-da! So 100 squared is 10,000, by the way. 2 times 100 times 2 is 400. And then 2 squared is 4. Add them up. Well, sort of. There's a subtraction there. 10,000 minus 400 is 9,600. Plus 4 is 9,604. There you go. Okay. Second to last, or no, there's a lot more. Okay, I'm going to try to make this quick, guys. So this is the difference of squares, not of if squares. Man, that means that I've probably made the same typo multiple slides in a row. Okay, so a plus b times a minus b. These are not squared, but they're very similar looking, obviously, right? The only difference between this being a plus b squared is the fact that it's being multiplied by a minus b. Okay, but guess what? This is one of the simpler ones. It's going to be a squared minus b squared. All right, so what's a in this example? Now, the reason we can get from here to here is the fact that if you were to FOIL, the things in the center, once you FOIL, cancel out, okay? And I really want you to take a look at this because you need to understand why it cancels out. When you FOIL, you're going to get a times b plus a times b. The only thing is the second b is usually a negative. So you're going to end up with opposites, and opposites cancel out. Those are going to end up canceling out, leaving you just the things on the edge, which ends up being a squared and b squared. Okay, so there you go. All right, let's go ahead and do this example problem. C squared plus 8 times c squared minus 8. Well, the a is c squared, the b is 8. So c squared squared, or c to the second power, is going to be c to the 4th power, minus 8 to the 2nd power, which is 64. That's your answer, guys. Wouldn't you so much rather do this work, especially since most of it's mental, than doing all of this business up here? Okay? Totally recommend it. All right. Here's your next power, and again, it's difference of squares, not if squares. And this is mental math. All right? This is the last slide, guys. Stay with me. So, if I have 59 times 61, both of them are very close to 60. In fact, there's a difference of 1 for 60 for both of these numbers. So I can do 60 minus 1 to get 59 and 60 plus 1 to get 61. All right? So again, this one still equals 59. This one still equals 61. I'm still doing this multiplication, but I'm turning it into a special case so I can do mental math a little faster. So A is going to be 60, B is going to be 1, and I'm going to get 60 times 60. Well, 6 times 6 is 36, and then add 2 zeros is 3,600. 1 squared is still 1, so it's 3,600 minus 1, which is 3,599. All right, sorry this took so long, guys. Good luck. Bye.